So in this video I'm going to go over some miscellaneous scripts which don't really fit in any other areas of the games. For reasons I'll explain why. They're just not really able to be organized with other things. So this is the persistent object, and what this does is this lives on a game object. So there's an empty game object in the scene, this script goes onto it, and what this script here does, it just makes sure that anything on this game object in terms of components are not destroyed when the scene is changed. This also has two method calls here. These are two things which are going to be called pretty much, then they're going to be called straight away. So it's just better off to call it here, because we know this is going to be in the scene, we know this is going to be persistent, and it's just a lot easier to put it here in one place. So the log.init, let's move this over there so it's in order. So this is my custom logging. It's not very special, it just appends any data that I deem useful in terms of debugging if something were to go wrong to a file. At the moment this is only really used in a few cases, mainly to save and keep track of stuff like video options that have been changed, notifications if something's been saved to a file, something's been loaded from a file, more core gameplay events. So there's just log.message where you just log the message, it saves it to a file and also prints it to the Unity console, and log.line which just prints a line in the file. So now we go to collision table.set initial collision. So these are the layers. These are layers in the Unity engine that are set up in our project. And what this is, it's kind of a central place to define if two layers should not collide. In this case, the player and the equipped weapon should not collide together, and also with the player with any minimap objects. So a few videos ago I talked about the in-game UI and there was the minimap, and on top of certain objects there was a coloured sphere that would show up on the minimap. So I've made it that the character cannot collide with those, in case for whatever edge case reason there could be a reason that they collide with it. It just makes sure that they don't. So that's the persistent object and the collision table. So now is another debugging element. This is what I call debug UI. It's just a small text element on the UI which just prints out variables to the screen. Some variables you can debug by printing with the console, but rapidly changing variables such as player velocity, the in-game time, are not very good in terms of keeping track of what value they are when they're printed out to the console, because it absolutely spams the console with tons of different values. Where if we just have it printed to the screen, it's just one variable on the screen, and rather than appending and going down in the list, it just changes it there and then. So it's much easier to keep track of that. At the moment this should not be used by anything, and it's not, because this is at the moment in the final version of our game and we don't want it on the UI. It may exist in the hierarchy but nothing's called into it, so it's fine. So this is the file that hosts all of my enums, well at least most of them. This is just a nice easy place to keep track of them all. Not all of them are used, this one is not used at the moment. I'll go into evaluation about why this is not used, but it's just a nice easy way to keep track. Epoch. So epoch time is essentially the number of milliseconds since January 1st, 70. This is used in a number of places, in industry and in my code base. In industry because it's just been there. And it's very reliable. It's not really set to cause any issues anytime soon. But also it's very reliable. So regardless of who uses it where, it's always going to be a consistent way of telling time. So time, in Unity, there's different variables that have to do with time. One being time.time, which is the time since the game started. But that might change depending if the scene loads, if something goes a bit wrong. It's not as bulletproof as this is. So during testing, I had some issues to do with time.time, with trying to figure out how much of a delay to put in between bullet shots when firing an automatic weapon. So, find all references. So this is used mainly in autofire. So with this is the rate of fire delay. And this, yes, I'm in the right base gun this time. So the epoch time is the amount of time. Then the next shot is also epoch time with a certain offset into the future in terms of milliseconds that will figure out how much to delay the shot by. So the next shot is the last shot fired, which is an epoch time, plus a shot delay, and the shot delay is just rounds per minute divided by a minute. Yes, a minute. This should have been commented exactly what this value is, but I'm pretty sure that 60 seconds is milliseconds. And what this does, it just gives a very accurate time scale in order to measure how much of a delay to put in between things. There was a bug with Apple devices with epoch time, where if you set the date of the iPhone back before this date here, it wouldn't boot up, and this is because everything was based on this going forward in time and not back. So, extensions. So, these extensions are method extensions. So this is almost a way to writing functionality of another object which you do not have source code for. So this is one of the easiest ways I've found to explain this to people. But let's just say we want to add this, we want to add a check to see if a game object has a component. So instead of having to write out this method over and over and over again, if you want to find out if it has a gun attached to it, if it has a weapon script attached to it, if it has a UI element attached to it, what we can do, you could call this like GameObject.getComponent, and you'd specify the type of component here. So it might be a rigid body, it might be a 2D collider, 3D collider, I'm running out of things to use. Oh, image, sprite, animator, anything like that. We can use this. This is the rough signature that it has to be in order for it to show up. So when I say show up, I mean like if I do GameObject dot, if we scroll down, we can use this extension underneath as an example. So we can use this like we can use this like if it was GameObject.getComponent, but we do not have the source code for GameObject, so we can't edit it and then use it as if it was part of the proper class. So we don't have the ins and outs, but we can use this extension method to kind of pretend that it does. But all functionality has to be written around stuff that you can get publicly from this. So GameObject.getComponent into self and parent. And what this does, it just checks the game object for a component in itself, and if it can't find it, it would check the parents. So instead of having to write this out every time you wanted to find this type of object in yourself and the parent, instead you can just call it like this. So has component, it tries to get a component, and then if it's null, then it doesn't have it. And if it's not null, then the game object has that component on it. This also covers things from times by. I did this because I think there was a really weird case where I couldn't use it. Oh no, so I'm not using this. So even if I'm not really using them, they're nice to have in case I needed to write something that may use them. But also, you never know when they're going to be needed. Same with this. It's this is not really the ideal case of an extension method, but it's nice to have because it's quicker than going collision.transform.compare tag. I can just do collision.compare tag. It makes the underlying source code a lot easier to read. Because in my mind, why do you need this middle transform here? Yep, so, and then with the resolution, if I want to display the string, but not in the Unity formatted way, I'd call this. The same with comparing resolutions. There's not really anything that does it on the Unity side. And you find in the local velocity, it's just things like this. Rounding decimals of a vector 3. Getting a random index from a list or an array. Kind of helper methods, so you don't have to keep on writing the same things over and over and over again. So, the way to define an extension method, it has to be public, static, and has to have a return type. And then this can be called whatever you want. So in most methods, it would look like this. Public static int to int and a boolean input. But now there's an issue where this method thinks it's just the public static method of this class. So to make the compiler know, no, this is actually a method for a boolean, you'd have to write this. So this boolean input. Hopefully that makes sense in terms of you're reading it like a sentence. But what this method does, if the boolean's true, it returns 1, and if it's false, it returns 0. At one point this was used for serialization to a file. No, as in terms of testing. I don't think this is used. Nope. And let's see if I've got an example of how I've used it. Where's round decimals? I know that's used. So, what? Oh, I've used 2 of them in succession. So, I've done character controller. I found the local velocity. That would be character controller.transform.inverse transform direction.character controller.velocity. So that's quite a sentence. That's quite a bit of methods and variables to find. And I can just call it by going local velocity. A lot easier to understand what it does, and also if we write it once we know it works, there's less chance of having a bug. And then we just want to round these decimals. And then we just define the effect we want to do it on. We can use default parameters here. I think I touched on default parameters in a previous video, but what default parameters are is if this does not have to be explicitly stated, like in here, so round decimals, it's set to 2 here. So if we specify nothing, it defaults to 2, but we can specify 5 and it accepts that as well. So it's kind of a way of having two method signatures in one declaration. It's very useful if there might be chances where you may have to use it, you may not have to use it. It's just easier just to define it once as what you would have it as default anyway, and then if you ever have to override it, you can do with very little issues. Yeah, then it just rounds it and returns the vector. And I think that is it for miscellaneous scripts. Yes, all of these are not my scripts. Okay. This is not my code, and I don't think that is anybody else's code either. I think that was downloaded from somewhere. Okay, so that's extension methods and miscellaneous scripts. My next video is going to be the evaluation. This will be only for people that need to see it, so you may not see it at all. But thank you for looking at my project, what I've programmed, and also hopefully the reasoning behind why I did certain things. Sorry if I haven't communicated things clearly enough. Any questions, please ask. Any issues that you think that you have that I've solved, give me a shout and I'll see if I can help with them. And enjoy the rest of your day.